Hey guys, we're going to start with our first investigation. It's found in Primetime Investigation 4.1. Our focus question this week is, how do you decide if a number is even or odd? And we're going to answer these three questions listed right here. What makes a number even? What makes a number odd? How are the models of even numbers different from the models of odd numbers? And how do even and odd numbers differ from each other? Okay, what makes a number even or odd? We've all heard even numbers end in 0, 2, 4, 6, or 8. But does anyone know why even numbers have to end in 0, 2, 4, 6, or 8? So we're looking for the why behind that. We've always heard that, but why? Why do they have to end in 0, 2, 4, 6, or 8? Okay, so for our next question, it says, how are the models of even numbers different from the models of odd numbers? So we're going to take a look at an example here. We have 6 pennies. So the number 6, we're going to justify our reasoning and decide, is 6 odd or even? Okay, but remember, the important thing about this example is proving how we know it's even. So we're going to show that with a model, a picture. And I just happen to use pennies. You can use whatever you want. Okay, so these 6 pennies right here, I'm going to take them and group them by 2s. Okay, so we're going to see how many times can we do that. Let's change to my mouse. There we go. So there's a group of 2. I'm going to move these over. And as you notice, we have 2 rows of 3. It makes an array. There are no pennies left over. We have perfect matches, 2, 4, 6. So that tells me that 6 is an even number. And I've justified my reasoning by showing that with a model. Okay, I don't have any leftover pennies hanging out over here. We've got even pairs that work out. All right, let's look at another simple number like 7. Okay, most of you probably already know whether it's odd or even. But remember, the important thing here is justifying our reasoning and telling how we know that it is an odd number. So we're going to take these pennies and we're going to do the same thing that we did on the other side. Okay, we're going to pair them up. So I'm proving and I'm justifying my reasoning by using a model. Okay, and as we notice, okay, we have an array with the 6, but we have this extra penny right over here, and it's kind of hanging out by itself. It doesn't have a partner. So in that case, we know that 7 is an odd number, and I justified my reasoning by using a model. So let's go back to our questions. Our next question says, how do even and odd numbers differ from each other? Okay, so now it's kind of time to put into words how we know even and odd numbers are different from each other. Okay, and we call these conjectures. So we need to base our conjectures, our claims, our conclusions on observations. So with our observations with our pennies, okay, we realized that an even number has to be a multiple of 2 because like our partners on our pennies, they matched up. There weren't any remainders. There weren't any pennies left over. So an even number, the definition is a multiple of 2. When divided by 2, it has no remainder. So 6 divided by 2 is 3. There's no remainder. So therefore, it's an even number. The definition of an odd number, it's not a multiple of 2. When we divide a number, an odd number by 2, it has a remainder of 1. So let's think about that 7. If I do 7 and I divide it by 2 like we did in our model, okay, we had a remainder of 1. We had 1 penny left over. Okay, so these are the definitions this week that we really need to focus on. We need to know that a conjecture is a conclusion or a claim based on observations. And then we need to understand the difference between an even number and an odd number. And we need to be able to justify our reasoning either in words or using a model. Thanks, guys.